We've downloaded our PAR data from the instrument and we've loaded it into R as a data frame called table. We've put together a couple of different text files that we downloaded, and also we got rid of some data that we weren't part of this deployment. But ultimately, we've put this all together by binding two tables together into table. And we have 5 columns here. We have our timestamp, our record number, our voltage differential, our panel temperature, and our PAR flux. So we have all our data, but right now we really don't know anything about the quality of these data. So perhaps before we go to all the work of making a data product, we want to make sure we have data that are valid and that are worth saving. That brings up the topic of quality assurance. So first of all, we need to pay a little bit more attention to how R is reading in these data. First of all, if we look at the type of these different columns in this data frame, I can look at the timestamp and it is a vector of character strings. But if I look at the type of the table column PAR flux, that one is double, which means it's a double precision floating point number, or it's a real number, it's numeric. So we have different data types here, but we never told R what data types to use. And that's something that R does a lot. It guesses at what to do, and it can run without an error as long as those guesses seem reasonable to R. So it guessed from what was in the data it was reading that this should be read in as a character string, and it saw that the characters that we're reading in were numbers, and it could turn those into numbers. So it guessed, you probably want numbers here. I'm going to read that in as numeric. Now, that guessing can be a problem if more things happen to files than you're not expecting. Sometimes you really don't want your program to work if there's something that you don't expect in the file. So you can tell R not to guess at these things, and sometimes it's a much safer thing to do to make sure you know what your program is doing. So let's scroll back up in our code. Let's go back to the read table where we're reading in the data from that first data file. And we can use the argument call classes in read table, and we can do a help on read table. You can read about what call classes does. Basically, you can give a vector of character strings that specifically tells this function what data types to read in for each column. So I can create a vector of character strings using the C function. And the first column needs to be a character string because I indeed do want to read the timestamp in as a character string. So I specify a character string with the character string character. The next column are record numbers. Those are just counting numbers, so we can use the integer data type, vector of integers. Now the next 3 columns are all real numbers, and the way we can tell call classes we want real numbers is using the numeric type. Now we need 3 different columns of numeric, so I could copy and paste this numeric 3 times, but there's also a function I can use in R called rep to create a vector of values by repeating a given value more than once. So if I say I want to repeat numeric 3 times, that will create 3 more entries or 3 more elements of this character vector that have the value numeric. So we can highlight just this call to C and we can run it. I'm going to hit Control Enter on a Windows machine. That's a hotkey for just running the code you have highlighted. And indeed, this will create a vector, a character string vector, where the first one says character, the second one says integer, and the next 3 all say numeric. And that corresponds to the data types we want to read in for the 5 columns of this data table. Now we can go ahead and run this code to see what happens. I am just going to highlight this line of code and rerun it to read in table. And you can see that I get an error. It says error in scan. That means it's running the function scan as part of read table to do its job. And scan expected a real but got this string NaN. And what this is saying is that it's trying to find a real number in the character strings in the text file, but it found this character string NaN, or quotes around capital NaN, in the text file. I can go to my files. I can go to my input folder, data logger downloads. I can open up this file. It's a big file, so it's going to say, are you sure you want to do this? And I'm going to use the search utility here by hitting Control F, and I'm going to look for capital NaN. Now there's a few NaNs here, but these are all data that we've deleted. We are actually starting here with our data. So let's not worry about these NaNs, but let's search from here. And sure enough, May 1st of 2021, in our original text file, instead of a parflex as a number, we have in quotes capital NaN. Now, what's R doing with that? If we go back to our table and we go to that date, that's early in the morning on May 1st, 2021. There's April 30th. There's May 1st. And 2:20 in the morning. Sure enough, in our original data file, we have the letters capital N, or I'm sorry, in our original data file, we had NaN, and what R has turned that into is an NaN. So that means that R guessed at what to do. It found this character string, capital NaN, and it said, okay, that looks like maybe what I would consider not a number, and there's actually a special value for real numbers that means not a number that I can assign that to, and that's what I'm going to do. Now, there are a couple problems with that. It's, first of all, the problem is you probably don't want R guessing. Like, you want to know if something like this is in your data. R shouldn't just do it without you knowing about it and you telling it how to deal with it. And also, we probably don't want that being NaN, because really what it means is data aren't available for that spot, for that particular point in time. So what that should really be is NA. And there's a subtle difference, but NA means not available and NaN means not a number. So NaN is the result of a calculation that comes out badly. But in our context of a data monitoring effort here, basically that NaN means we have one data point we tried to take a measurement, but for whatever reason, it's not available. So we don't actually want that to say NaN, we want it to be the Na type. So that means right now we're getting an error. Like, it's trying to turn that into an NaN, and this error is actually a good thing. It's better if we know that stuff like this is happening rather than our guessing. But now we don't want an error to prevent our code from running, so we have to do something about it. And there's another argument to read table that gives you specific control over which character strings it might find that R should think of as representing NA, or not available. And that argument is na.strings. Again, we can go to the help, and you'll see there's an na.strings argument right there for read table. And in this case, that is going to be capital NaN with quotes around it. If I go back to my text file, I need the string quote NaN quote to be something that shows up as an NA. And that's because this is a string that is consistently going to be sent out by a Campbell data logger when there's a problem with the data for that data point. Now, I need the quotes as part of the string, but I'm using quotes to delineate a string in the R programming language. So the way you deal with that is using the escape character, or the backslash. So if I want to put a quote inside quotes like this, I need to put a backslash to say, don't look at this as a quote. I want you to put the literal quote inside the character string. Then I need a capital NaN, and then I need another literal quote, or escaped quote, so that all of this together represents quote, capital N, capital A, capital N, quote. And now R knows that it should turn that into an NA. There we go. There we go. Now I need to skip past this 2020. There it is. And here's 2:20 in the morning. Now, instead of NaN, it just has an NA. So when you're dealing with data, generally it's better sometimes if your code will break if it comes across something you're not expecting. Because if it guesses something and does something and doesn't show an error, and that guess results in an unexpected value in your data that your code isn't set up to deal with, then you might have some problems further down the line. So part of quality assurance is just making sure that what you're reading in is what you expect. So I personally like to do this every time I use read table. I like to tell it specifically what data types it should be reading in, so it will break and I can tell it specifically what to do in various scenarios so I know exactly what's in my data set moving forward from this point. So we can use this idea in all of our calls to read table. In this case, this is the read table I'm using to read the headers. So I'm going to put in call classes equals character. Now you might ask, why are you putting just one character string here instead of a vector? But recall, when I do this, it's actually going to be a vector. It's just going to have one element. And remember that if you give R a vector that's too short, it will just recycle that vector. And in this case, all of the what it reads in, every column should be a character for the headers. So I want to read them all in as characters, so it's okay to just put a single character here, and R will automatically recycle that for each of the 5 columns that it reads. And then we need to reuse this. We're going to do the same thing for the second table. Here's where we're reading the headers for the second table. Don't forget my comma. And here I can copy and paste this code to my other read table for reading the data from the second file, because the data have the same format: a character, an integer, 3 numeric values, and they're all Campbell data files, so any lost data are going to have this NaN in there, and I want R to turn those into Na values because it's data that aren't available. So now I should be able to rerun this whole chunk. I'm going to hit Control-Shift-Enter. I could also go up here and hit this arrow. And I'm going to go back. I can close this CSV file, and I'm going to look at my table. And now if I go again to that May 1st, there's April 30th, May 1st, 220. Again, I've got that NA. And now in this whole table, I should have NAs anywhere there was an NaN.